Hi everyone, thank you for coming. This will be our new Diffs SSR proposal overview call. First of all, I'll give you a brief overview about the approach with a small demo and presentation. And then we can discuss, maybe someone has some questions and I'll try to answer it. Okay, can you see the screen?
Apparently not all of it.
Yeah, it's cut off.
Somehow shifted.
Okay, give me a second.
Much better, thank you.
Good.
So last year we've started an effort called New Diffs. And in this small presentation, I'll tell you what's it all about and share with you the SSR architecture proposal. Let me start by explaining what diffs are we talking about. We have two types of diffs at GitLab. On the left, you can see commit diffs, and on the right, merge request diffs. Commit diffs could be found on commits page and also on the compare branches page. Even though commits and MR diffs look very similar, they are in fact quite different in the architecture. So commit diffs are quite simple and often require page reload to interact with them. They are written in HAML with most of the logic stored on the server. And we render them on Rails and add sprinkles of JavaScript to them on the client. The UI logic is written in pure JavaScript without any frameworks. And then we have merge request diffs, and they are quite different. They have a lot more logic, which is mostly written in Vue, and they are fully rendered on the client with diffs data fetched from Rails. To give you an improved client-side performance, we are using virtual scrolling to render them. So what are current problems with these approaches? The combination of server-side and client-side rendering comes with a set of disadvantages. I'll focus more on the problems with MR diffs, but some of these issues also apply to commit diffs as well. The way we currently render diffs on merge requests has a perceived slowness to them, which I'll explain a bit later. We also take too long to fully render big merge requests with hundreds of changed files, which may cause browser freezing or even crashing. Because of issues with client-side rendering, we've applied virtual scrolling to render diffs, but it also brought several bugs like unreliable scrolling and missing files in your viewport. And the virtual scrolling also doesn't work with in-browser search. So if you press Ctrl F, we actually have to fully re-render your whole app, which causes a browser freeze for about 5-10 seconds. So client-side rendering is not the best choice when pairing it with Rails. You have first to wait for the document, fetch your assets, and handle subsequent requests. The performance of client-side rendered app is also heavily dependent on the client machine capabilities. As you can see in this graph, we are delaying our first data request to the server, which increases the time to the first visible diff. So what are the new diffs that we are working on? With the new diffs effort, we'd like to improve the perceived performance of the diffs at a cost of developer experience. The diffs must feel snappier, and we should have struggled with big MRs as we do right now. The new architecture also should cover both merge requests and commit views and improve accessibility. And here comes the proposed server-side approach. With this approach, we'll move most of the rendering to the server to improve the perceived performance. To explain how it works, let me talk about the classic SSR approach first. We already use that approach on the commits page, but it has its flaws. Its main downside is that we have to wait for the whole response to be generated on the server before seeing anything. That includes fetching JavaScript and CSS assets as well. Our page starts to feel progressively slow once we increase the amount of diffs we need to render. And how are we going to solve that? First of all, we eliminate the slowest part, which is rendering lots of diffs at once. Instead, we'll only render a small portion of the diffs so you can start reading the changes right away. To get you the rest of the diffs, we'll use streaming on both Rails and client side. This approach differs significantly from similar solutions to the SSR problem. Most of the solutions use buffered responses and insert HTML at once. With streaming, we'll be serving users diffs as soon as they're rendered on the server. In order to make these diffs interactive, we'll still use Vue, but with web components used to connect Vue apps and rendered HTML. And lastly, we plan to heavily rely on caching of the rendered HTML, so page reloads feel super snappy. The streaming works by sending HTML bit by bit, and the browser can render HTML progressively, so we can start rendering our diffs immediately right away. The benefits of this approach are clear. You can start reading diffs much sooner. This is especially important for big merge requests with many files changed. As you can see on this example, the left page only has finished loading while the right one was visible right away. Next technique is to use static and dynamic UI separation. In order to get the benefits of server caching, we must separate our static and dynamic parts of UI and store the static parts in the cache. Everything else that is dynamic could be then progressively added on the client using JavaScript. And the cached parts can be shared among all of the clients. We'll also use web components to connect our existing Vue apps to the Diffs HTML. They are a good fit because we can offload low-level DOM operations to them, and they also eliminate the need for mutation observer when we stream our HTML. Since we stream HTML in chunks, we cannot rely on this HTML structure yet, so we have to use either mutation observer or web components. Since web components provide a better abstraction layer, we prefer to use them. And here is a graph that shows the main difference between our current client-side rendering approach and the proposed server-side approach. As you can see, we have significantly improved the time when the first diff file is visible to the user. Our perceived performance has improved, even though our document arrives a bit later now. You can also see the main difference in how diffs files are presented to the user. With client-side approach, the diff files appear in batches with a significant delay. Server-side rendering with streaming allows us to display diff files as soon as they're ready on the server. And here's how it compares in terms of perceived performance. This test was done using unoptimized HAML templates from the commit diffs. So you're seeing the worst case scenario here. Also, the testing was done with all caching disabled. As you can see, the SSR approach delivers the first diffs almost twice as fast at any scenario. Please take note, this approach needs validation before it can be applied. First of all, this is intended only for performance critical cases like the merge request page. Secondly, you need to have a lot of user data as your input. Otherwise, the DX overhead doesn't make sense. So let's see it in action. So right now I'm loading the Diffs SSR proof of concept. This is how it looks. The part you are seeing on the right, this is using HAML template from the commits page. And let's see what happens if we disable JavaScript on this site. So as you can see, we already have 5 diff files coming from the server from the get-go. It doesn't need any JavaScript. We can just apply CSS and we already can start reading the diff. If we return JavaScript enabled and see our network, you'll get a better understanding how it works in order to give us the rest of the diffs. As soon as we see the sidebar, it means our JavaScript has loaded. And this is our request for rest of the diffs. As you can see, it takes quite some time to get finished. But in reality, as soon as 2 and 7 seconds pass, we can start rendering this right away. So as you can see, the page is fully loaded and it was loading actually progressively. For example, if we go to this request in a new tab, you will see that it already starts rendering diffs and all of them are rendering progressively. So we don't need to have to wait for the whole request. Also, take a note at the sidebar. Let's try to reload the page once again. As you can see, some of the entries in the sidebar are grayed out. That's because not all of them are loaded at the moment. And as soon as file appears on the client browser, it gets darkened. So you can actually see the progress of the files loading in your file browser. So how does it actually work? I'll show you some small examples of the code. First of all, in order to get this working, we need to do two things. We need to start rendering the streams. So here we are getting the request to the server and use our render HTML streams function, which is already working on the blame page. So the HTML streaming is already written for us. Then we need to define our custom elements for diff file. So this is applying diff file custom element once it appears on the page. So as soon as it is streamed from the server to the client, this class will be called, and then we can start connecting our diff file HTML to the Vue app. In this example, you can see we render discussions, which are client-side element with this web component. So it doesn't handle all of the discussions logic. It just attaches the Vue app to the discussions element. And here's how it looks in the HAML template. So we have this diff file, which is used in the commits page. And we add a web component at the end of it to indicate that the file has been loaded. And the custom element attaches to actually this element. And that's basically how the client-side side works. That's how we achieve streaming with Rails. So we have this Diffs page endpoint, or you can use this. So as you can see, it's using the Diffs page endpoint. This is where we go to get the stream. And all we have to do is use response.stream and write the partials as soon as they're rendered. And that's basically everything that I wanted to show you.
Hi, Stanislav. Thanks for sharing this. Can you go over how you fix the rendering problem? Like what's the chunk of the stream and how you don't render like broken HTML, basically?
Yeah, the JavaScript API provides a function that basically holds a buffer of what has been rendered. So if you, I'll even can show you an example. Give me a second. So we have this render HTML streams function. This is how we add HTML to the document. We actually create a new document and start writing as, like, you might have seen the code written like this document that I wrote many years ago. This is exactly that, but in a separate document. And give me a second. Yeah, this is how we achieve a unified stream of characters in HTML. So this decoder is a text decoder in UTF, and it can accept bits. If you provide it with a stream flag set to true, it will understand that the next byte you are sending to this decoder is a part of a UTF character. So it doesn't matter how you split your stream. It can really understand how to connect all the pieces together so you don't end up with broken HTML. Does that answer your question?
Yes, it does. Thanks. Which reminds me of another question. We're injecting HTML in the page, and there's like all of those security issues that might come across. So did you have anything to prevent this kind of issues?
I've tested this approach with injecting script tags and also injecting images with onload attribute. Neither of these worked, so I think this is really safe for use. We already have this on the Blame page, so if you actually go to any Blame view at GitLab right now and click on View Full Blame File, you'll have this streaming working in your browser right now.
Does this need to load everything? Does the server side need to load all diffs in memory before streaming them, or can we also iterate through them?
Yeah, that's a good question. We actually identified the slowest parts in the app when it comes to backend side. It seems like the slowest parts were applying code highlighting and also fetching the whole diff from Gitly. In this demo I've shown you, we fetch everything else from Gitly first and then do highlighting per file. So we highlight a file, send it right away, and repeat this process until we reach the end. I think this can be optimized. We are looking for ways to make it faster, maybe applying pagination on the Gitly side, so we don't have to fetch the whole request from Gitly and also stream it right away. We haven't tried that yet, So maybe in the future.
I know that there's some code, but I don't know if it's still used, that did this kind of like tiered approach where we stored, like, bad thing, don't do this anymore, but where we stored the diff in the database, and then it eventually got stored in object storage. Have we considered reusing that approach? Because in some cases, I think loading stuff from object storage might be faster and definitely cheaper than loading it from GitLab. And if we can store the already highlighted bits in object storage, then that's another step that the server doesn't need to do. I'm not saying that this is going to be easier and so on, but yeah, worth considering.
Stas, if I may address something that Bob touched on. One of the things that came up already is like not every diff will benefit from long-term persistence. So for example, if you're watching at a compare branches between two branches, they're ephemeral, they don't have a merge request, very unlikely to have frequent accesses. Whereas merge requests will be a special kind of diff. So somewhere in this application, there will be some preference to persist some diffs, but not all, in a like quicker way. The biggest change so far, I think we've seen, is that until now, the diffs for MRs were stored in the database. We stored the data structure so that we can then push it out in JSON for the front end to work on it. With this change, the parts of the diffs that are server-side rendered will now be more easily cacheable because we're just caching the static diffs, the static parts. We're not caching the user preference, the user-specific parts. So that makes it even more prone to heavily caching a rendered HTML on Redis, for example, which until now we wouldn't choose to do so.
Yeah, well, Redis is not a great candidate for caching huge blobs of data at
Sure.
once. It doesn't really like that. But
I misspoke. Somewhere that caches full HTML rendered, but we don't have a preference specifically. But yeah.
No, that's the reason I mentioned object storage. But even Redis for small merge requests and so on might even, like, we could have a threshold. That's just dreaming now, no? But we could have a threshold like this is small enough, just put it in Redis and then stream the thing out of Redis and into to the client. That'd be the fastest.
There's another component to this. I don't know if it fits into the discussion, which is the revisions. So if you force push, you updated the branch, rewrote the history of the branch, and when you compare, you have the comparison possibilities in Git, but there's also, you can access the revisions on merge requests. I don't know where this is stored, so there's that as well.
Yeah,
So
if we separate dynamic and static parts, we can get a stable cache key for each of the version you are looking at. So that shouldn't be a problem, but the specifics of the caching can be decided later. We are just giving the possibility to cache it at every single moment. And how we are going to cache it, that's another discussion, I think.
What needs to... Igor had his hand in the air.
Yeah, just one note here that we actually looking for a GitLab pagination. Yeah, this is the performance improvement that we definitely plan to do, because, for example, even for rendering these first 5 files for a huge merge request, we still need, currently we still calculating like the whole commit diff for the whole merge request. So currently, we're looking for the way for GitLab to render, for example, diff for a particular set of files. Yeah, so we could do it faster. So this is the optimization that we definitely plan to do in the beginning. And regarding caching, we still considering our options, but now I think maybe there's we can consider an option of caching the first 5 files, because we're really interested in rendering them quickly, and maybe it's not a huge data to store in Redis, and we can consider it like this option. Yeah, something I wanted to mention.
More questions or concerns that this raises?
What's keeping us from using this now? Like iterating on the proof of concept that Stan just showed us and going from there? Because that looked promising.
I think this is one of the next steps forward. Also, I've just checked how the XAML view works for the commits. And it seems like that the commits XAML view does extra Git requests. So for each render of the diff file, we do a single request. So we're having an n+ problem. If we remove that, we can already, I think, get twice faster response times from the streaming, which might be also worth exploring. We also have a call in 2 days about Workhorse. So maybe we could use Workhorse to improve the rendering of this, because Rails is not the fastest language in the world. And since we want the best performance, we might go with that. Yeah.
So to your question, Bob, I also got excited when I saw this, so I totally understand it. So for context, we're in the blueprint authoring stage of the new diffs. So we're looking to finalize that blueprint soon, by the end of this month or something, so that we can then start implementing soon after. I wanted to mention here, while it is tempting to grab these proof of concept that Stanislav and Igor and everyone has been collaborating, just push them out to code. We're looking for a long-term re-implementation of diffs that supports like all cases of diffs across the board in a reusable fashion, in a sustainable fashion. We don't want to get ahead of ourselves and ship something that will have, that will be raising concerns from the front-end team later on, or the back-end team, or Gitly. So we want to make sure that the architecture is confident enough to, or we're confident in it enough to go ahead for implementation. But yeah, we're very excited about the potential of this. And namely, this layer of the web components is one of the newest things that so far we've used it for smaller things on copy to clipboard buttons or something like that, but never at this core part of an architecture of a front-end application. And we're very curious to see if there's anything we haven't come up with, any problems or concerns. So we're looking to push this out as soon as we can, but not rush it, if that makes sense.
Yeah, because I think I think we might end up with a more maintainable situation than we have now, because previously we had some stuff on the back end, we moved some stuff to the front end, but the back end stuff's still there, and we don't know. Like today, I learned that the commits thing is still using the old.
Yeah, we've always known the people that are close to it, but unless you look for the specific things, you just notice that, oh, why isn't this feature here on the commits, or why is this still shows a little 3 dots and not the little arrow thing. So there's a couple of signs you can totally tell, but yeah, we've known for a while. Any more thoughts, especially from the front end folks, about custom elements and the way that we're using that to glue? Any concerns there? Any questions?
I guess I have a question. So you also showed that this completely loads without any JavaScript, yet the web components and the stitching that you showed for the streaming, that is all JavaScript. So how does that exactly work like that?
Well, we still need JavaScript to, first of all, make the request to get the rest of the divs. So it starts a fetch request, and then we need JavaScript to attach it to the document, because when you see this first 5 diffs, that's everything that we serve from the server in this first request. The rest of the done with JavaScript, but the heaviest part of the work is performed by the server. So we are just reusing the HTML from the server. We are not building it from the scratch. We are not using data to build our HTML. We are just attaching it to existing document. So that's when the JavaScript kicks in. And then we start building our UI on top of it as well.
I see. So without the JavaScript, when you scroll down, then you see basically empty page because nothing gets added.
Yep.
And
Yep.
so when you actually interact with the front end, like let's say you change some sort of settings, like you want to see the empty spaces or something like that, everything has to reload.
It works the same way as it works right now. So if you go to merge request and start, like you remove, you start hiding white space changes, it basically causes for the diffs to be fully re-rendered.
Mm-hmm.
This is not very different from how it works right now.
I've seen a lot of times, probably a lot of people here who interact with this daily have seen like a strange stuff happening. Sometimes the counts are completely off or they change when you scroll down and stuff like that. Will this improve that? I hope so.
We also hope so. Yeah.
Okay, thanks.
Yeah, thanks, Tomasz. I think that those wrong counts and everything, they're more related to changes we've done recently about asynchronously creating the MRs and trying to keep up with the changes in the UI and all that stuff. Part of rethinking the diffs is also to get all those lessons into this new application, and we'll hopefully avoid those pitfalls for you. But not at this stage, with a very proof of concept stage. We just want to make sure that we test the big changes. The HTML isn't optimized and all that stuff. So we definitely want to still take a good look at that part of the user experience. I wanted to call out one specific thing where we don't aim to have the page function without JavaScript. That's not a concern at this moment. We do have concerns for accessibility, that we have some parts that will make sure that the page is navigatable with keyboard and it will be accessible, that sort of thing, but not with the JavaScript off. So that's not a concern. That's just a side effect of the approach we're taking. One thing we do gain with this is that line that Stanislav showed of like the first line, the first diff rendered, we don't have to load Vue and Apollo and all that stuff to be able to show that to users, because it's natively supported by the browser. So it's pre-declared with the application, those custom elements, and they'll just kick in immediately, and then we can just go from there. So we do gain some time there. But the overall, another aspect of that is that we control very much the low level operations, like Stanislav showed, or what happens to those elements and how we connect that to dynamic part of the application.
Thank you. I think it's awesome, by the way.
Thanks.
I was curious as well. You mentioned the web components part. So if you're streaming HTML, why not have like just a save HTML directive on an empty Vue component and then let Vue do the thing?
Well, we can do that, but how do you figure out when we are ready to attach a Vue component to a specific part of the app? So this will basically require you to send lots of data in chunks and run a Vue app for each one of them. And we figured pretty quickly that running lots of Vue app instances is really heavy on the memory side. So if you go to any merge request with like 100 files changed and you check how much of memory you're using, you'll be surprised that it takes like 500, 600 megabytes of RAM to render this. And this is already optimized. So we are trying to reduce the load on the client as well here. That's why we're going with pure HTML solution and with web components. Also, the web components allows us to apply optimizations on top of it. For example, if you don't see a diff file in a viewport, we can even skip rendering some of the UI because you don't need it at this moment. And that also reduces load on the client.
Yeah, that's the exciting part, using intersection observers to like make the chunks dynamic as the user goes, prevents us from using memory just to load ahead. So essentially it's a mix between virtual scrolling, but keeping the content that users would be looking for in it. So for example, discussions, we might want to attach the discussion so you can search the discussions, but not the buttons of the UI on a diff. Like nobody's going to search for that, I guess. And if they do, I mean, yeah, they'll find the other ones, the other 1,000 files, but until they get there, and then it will load.
Lawrence, you had a question?
Yeah, I think it was kind of asked by Sheldon, but yeah, first of all, thanks for the demo. It's really interesting. But I was curious about whether you had any thoughts about using web components even further, because now you're still. But then you answered like, yeah, if they're not visible, you don't even need to load them. But could you go even further with web components and get some of the view things we're doing in the web component itself, or does that really hamper even further the dev experience, I guess?
Well, in theory, we can do that. Nothing stops us from writing all the code in pure JavaScript and combining it with web components, but we have a lot of logic already written in Vue, and it would be kind of a waste to throw it all away and write it from scratch. So we plan to reuse most of the logic that is written in Vue for stuff that is interactive. So for example, for discussions, we can reuse most of it. We just need to attach it to a web component instead of a other Vue file, for example. And that goes for other stuff like dropdowns, headers, collapsing, marking files as viewed. We can all reuse that logic, and we use web component to basically aggregate all of these Vue components into a single web component.
Nice, thanks.
Yeah, we're not looking to replace Vue at all. We definitely understand the benefits of it and how it plays into our whole strategy. And you know, GitLab UI is still will be a part of like the how we built this application, and we need to import the markdown editor and all that stuff. So that is always going to be part of the application that we build here. But we definitely want to get a quicker get the app quicker up and running for users, I guess.
Thanks.
But I think Stanislav touched on a point. I want to just expand here. We don't see this pattern, this approach for every single case on GitLab. But for highly intensive applications, we could totally make this architecture part of an approach. So like see how it works.
Issues with a lot of comments, would that be a use case, or is that still not that intensive as merge requests and diffs?
You mean discussions on an issue? Or issue
yeah, discussions or a very long thread or.
I think that's a case where I've seen issues that definitely would qualify with thousands of discussions over the years. So I'm guessing it depends on how, I don't know, the length of it. We haven't defined a specific limit. I think it's up to the teams to define what disqualifies, because there is sort of like a point where the cost of overcomplexity, of bigger complexity, doesn't pay off on the benefits of it. So if you're struggling with performance, I think that's kind of like what a good litmus test is. Are you struggling with performance on your pages? Are your pages blocking the browser and you're struggling to deal with all the data you have to put on the page? Maybe yes, maybe consider it. If the page is smooth as it is, and you're getting by with just patching, maybe you can get by with that. Because that was the journey we went through on the diffs. We first rewrote it into Vue by using all the tree component, by the natural components that we used in Vue, by breaking it all into small bits that made logical sense for the developer, and rely on Vue to discern between what needed to be reactive, what didn't need to be reactive. And the browser just couldn't keep up with all that, the tearing down and all that stuff on the component browser side of things.
I'll also add that we don't plan to allow users to render any amounts of changed files in a single page, because that would be just unreasonable to let them render 1 million files in a browser. So I think we'll be setting a reasonable limit to how many files we can view, with maybe an optional opt-in to view the whole merge request. And that also applies to overview comments on issues. I don't think you ever want to render anything at once, because I don't know a technology that can render text in an unlimited amount in browser.
Any more thoughts, questions? I can throw one out there. One of the things we're very mindful is that the payload will probably increase in size that we're transferring. If you strip out all the UI for dynamic stuff and we just send the HTML rendered, syntax highlighted from the server to the front end streamed, overall, maybe that amount of bytes that were transferred will be maybe even larger than we have today, because we're sending just the structured data, we're not sending the markup. But we're seeing one of our priorities in this project is perceived performance. So that's why we're trying to balance this. It's a balancing act between keeping the markup as nimble and as lean as possible. So that's why this is an optimized markup. We want to rewrite all of that layout to be as lean as possible. But also we know that this will come with the benefit of highly cacheable, quicker to respond, stream directly to the page, and it will just be lighter on the client instead of having multiple requests, multiple things happening at the same time with Vue overall. So that is on our minds. So we'll definitely keep an eye on that. Meaning that I don't want us to the end, get to a 5 files diff and loading 100 megabytes of HTML on the page. So we definitely want to balance that.
On this topic as well, how's the relationship on the network side? Are we firing requests in parallel? What is like? Is it per file or is one string for everything?
So I've linked 2 implementations in the document. So the first one using pagination, we are splitting, I think, in batches of 20 files per request. And the second one uses streaming. So it's a single request that I've shown in the demo. With a single request, we first get all the files from the GitLab and render them one by one and stream it back to the client. So with a single request, we finish all the diffs.
Currently with the blame page, we don't do that, right, Stanislav? So we'll send a chunk, several requests in parallel, and whenever they resolve, right?
We figured out the streaming Rails part last week with the help of Igor. So thanks to him, we can actually use this implementation. Yeah, we didn't know about that while we were working on blame page.
You live and you learn.
Would it be any benefit to have like requests per file or any sort of like pagination like this?
Yeah, I think Igor touched a bit on this. So the main downside with fetching all of this with a single request is that you can have a very long response time from GitLab. For example, you have 1,000 files changed. You have to fetch all of them in order to start rendering the first file. If we figure out pagination for the GitLab side, it will make sense to paginate the GitLab calls and also paginate our client-side calls, so we can start rendering even faster. If, for example, we use our current approach and split all the requests file by file, we'll be adding 2-second overhead to each request because we have to fetch all of the diff files to render just one file.
Maybe perhaps a hybrid approach, like you delegating the Gitly part to workhorse and have the this output in some form of cache, and then in the Rails side we do per file.
Yeah, I think the exact approach that we'll take will depend on the performance of Gitly, if Gitly supports pagination and it is fast enough, and if Workhorse even works out. Yeah, definitely some mixture of these approaches will be in the final implementation, but I don't have the specifics right now which will be faster. Right now, the streaming approach and the paginated approach, they are on par in performance. So they finish almost in the same time.
And that's the worst case scenario because it's not optimized and it's not cached and all that stuff. Stanislav, do you want to mention the call you're having on Wednesday? Think it's relevant?
Yeah, one of the ideas to improve the performance was to completely get off the Rails for the rendering part and let the workhorse do the actual highlighting and rendering HTML. I think we found that the slowest part of this equation will be calling to database, and that will be handled by Rails. I don't think we have a way to skip that. So we'll have to definitely call Rails to fetch the permissions, for example, and fetch the exact commits that we need to get from Gitly. And after that, we can be highlighting and rendering diffs in parallel and then streaming them back. So that's what we'll be discussing on Wednesday.
A question, are we doing or have we considered caching the diff files maybe per their SHA hash on the server or on the client, or are we doing it now? So that when you look at a large diff or an MR, you have particular files where we could cache the rendered at the end HTML, which you are envisioning like a table as far as I read here. And then we could query back on Redis those diff caches, and they have a unique key, I think, based on their SHA and also file name, etc. What is the status quo and what is the plan? And even finally, could we cache with an unlimited local storage on the client certain rendered diff? And why doesn't it make sense? Maybe. Yes.
Yeah,
it's a fantastic question. Go ahead, Stanislav.
Yeah, with cached approach, we are making sure that we enable all kinds of caching in the future. So since we have a static part that is common for every user, we can, for example, cache it on the server as you described by SHA hash. We can cache the whole merge request because of that. And also we can use client-side caching using e-tags, for example. So this will be handled on the HTTP side. And in this case, you won't even have to make a request to the server. It will be delivered right from the client. It also won't involve any JavaScript from our side.
Yeah, I want to mention some things we did look into. So I linked an issue that that came out of a performance roundtables we did in code review. That was exactly to, whenever possible, render the diffs from a client-side cache unless the ID is outdated. We've talked about the patch IDs already that we have worked on. This ended up with some improvements on the e-tag side of things, but we also looked into leveraging IndexedDB locally to cache the structure of the diffs and render from there. Thomas did a POC on that, Thomas Randolph. A lot of questions came from that, where that would benefit a repeated visit until that MR is outdated. So the window of repetition would be just like give 1 or 2 loads for a reviewer. And then as soon as the author pushes a new commit, that diff would be outdated again. So we definitely have that in the back of our minds. It's not top priority at the moment. We also came up with some potential risks of caching things in clear on the browser that could be easily parsed. And then the user losing access to a project permission-wise, and then they would have an entire list of MRs cached in the browser. Not a huge problem, because once they had access to it, but they could reconstruct the MR. So there's a bunch of like questions we've looked into it. Not top of mind right now. We definitely want to optimize the render as a whole, but I wouldn't be surprised if later on, because of these changes in the caching, allowing the content to be much easily cached, that we start leveraging something like offline diffs or something. And we use a service worker to render the page if you're offline or something, with some features disabled, but that's later down the line, I would say. It's a great question, though. Any more thoughts, questions?
I think if anyone has any more questions or maybe thoughts about that, you can use the POC link, either of them, to leave your comments, and yeah, we'll try to respond to them. Yeah, thanks everyone for coming. I think this was really productive. Thank you for giving your time into this. Thanks a lot.
Thank
Thanks,
you.
Stanislav. Great
Bye.
presentation.
Thank you. Bye.
See you.
Bye.